Okay students, now in this video we are trying to prove some important results. So here we are given that if a function f from a to b, function f from a to b and another function g from b to c are 1 1, two functions are 1 1 function. So if we consider the composite of that given two functions, that is go from a to c is also 1 1 function. So if two given functions are 1 1 function, then their composite function is also 1 1 function, that we have to prove. Done. So here what we are given, function f from a to b is 1 1 function. So we have already discussed how to prove a given function a 1 1 function. So what we are doing for this function to prove it's a 1 1 function, so we are taking two elements x1 and x2 from the domain. So let's x1 x2 belongs to a. Done. For this function two elements belongs to domain. So then we are checking if f of x1 equal to f of x2, f of x1 equal to f of x2, which implies x1 equal to x2, we can say given function f is the 1 1 function. And here we are already given function f from a to b is the 1 1 function, and therefore we can write f of x1 equal to f of x2, and then we can implies it's a x1 equal to x2. For the given two elements, two equal elements in a domain, we are getting two equal images in codomain. So this is the mathematical explanation of 1 1 function. Now we have to prove this composite function go from a to c is also 1 1. So what we have to prove? We have to take two elements x1 x2 from its domain. So here let's say two elements x1 and x2 from the domain of this composite function gof. Done. Now if we can prove what f of x1, so here gof of x1 is equal to gof of x2, and this is equal to, if we can prove x1 equal to x2, we can say this composite function is the 1 1 function. So now this gof of x1 can be written as g of f of x1 equal to g of f of x2. Function g from b to c is also 1 1 function. That means from that means for x1 x2 belongs to a, we can say g of x1 equal to g of x2, that is equal to x1 equal to x2, and therefore we can write f of x1 equal to f of x2, as g is also 1 1 function. Now f of x1 equal to f of x2, and here it is given that function f from a to b is also 1 1 function, and therefore we can write x1 equal to x2. Hence we can say for x1 x2 belongs to a, g of f of x1 equal to g of f of x2, and it implies x1 equal to x2, and therefore we can say gof from a to c is 1 1, is 1 1. Clear students? So pause this video and note it down. Okay students, now result number 2. Here we are given that two functions, function f from a to b and function g from b to c are onto function. So if these two functions are onto function, then composite of these two given function f and g, that is for a gof from a to c, is also onto function. So if two functions are onto function, their composite function is also onto function, that we have to prove. So we are given function f from a to b, function f from a to b is onto function, function g from b to c is onto function. We have to prove composite, that is gof from a to c is a onto function. These two functions are given function which are onto function. We have to prove this composite function is the onto function. Done. तो कैसे प्रूव करेंगे? देखो, व्हाट इज द ऑन टू फंक्शन? पहले तो डेफिनेशन, A function is said to be an onto function if all the elements of its codomain, all the elements of this codomain are occupied. मतलब all the elements of codomain must have pre-image in domain. That means कोडोमेन के अंदर जितने भी एलिमेंट होंगे वो सारे एलिमेंट के लिए कुछ ना कुछ प्री इमेज उसके डोमेन में होनी चाहिए. दैट इज द रिक्वायरमेंट फॉर एनी फंक्शन टू बी ऑन टू फंक्शन. डन. सो इफ वी कैन प्रूव for the all the elements of this codomain, that is C, has some pre-image in this A, we can say this composite function GOF is onto function. Done. So let's assume the set of all the elements of this set C are nothing but the Z. Set of all the elements of this set B are nothing but the Y, and set of all the elements of this set A is nothing but the X. So here we have to prove this GOF is onto function. So let's start with this C. That means for all the Z belongs to C, all the elements of this codomain of this function G, for all the Z belongs to C, there is some Y belongs to B. Why? Because we are given that this function G is onto function. फंक्शन जी ऑन टू फंक्शन है, दैट इज गिवन. इसका मतलब क्या हुआ कि ये जो कोडोमेन है, दिस इज डोमेन एंड दिस इज कोडोमेन. तो जो फंक्शन जी का कोडोमेन है उसके अंदर जितने भी एलिमेंट होंगे वो सारे एलिमेंट के लिए कुछ ना कुछ प्री इमेज डोमेन में होगी. तो उसको हमने अज्यूम कर लिया. लेट्स सेट ऑफ ऑल द एलिमेंट्स, दैट इज जेड, ऑल द एलिमेंट्स ऑफ कोडोमेन. फॉर ऑल द एलिमेंट्स ऑफ कोडोमेन देयर आर सम प्री इमेजेस इन डोमेन. डन. देयरफॉर व्हाट वी कैन राइट, we can say, therefore what we can say G of Y equal to Z. G of Y equal to Z. For all the elements of this Z there is a pre-image in B. So G of Y equal to Z. Done. This is from the result or given function G is onto function. Now students, we are also given that function f from a to b is also onto function. So here we can say for all this y belongs to b, for this all y belongs to b, that means all the elements of this codomain B, there is some pre-image in set A. So for all y belongs to b, there is some x belongs to A, where x is the pre-images of this element y. So for every y belongs to B, there is some pre-image in set A, and therefore we can say f of x equal to y. Done. Now what is the composite of these two functions? It's a GOF x. So now from this both the result we can say for every z belongs to C, some pre-image is in set B, and for every y belongs to B, there is some pre-images in A. So by combining this both the result, can we say for every z belongs to C, there is some pre-image in X? Yes. So we can say for every z belongs to C, there is some x belongs to A, and therefore we can say for every z belongs to this C, there is some x belongs to A, and therefore we can say this GOF x equal to y. GOF x equal to y, and hence we can prove this GOF x is onto function. Done. So this is how we can prove if function f and g are onto function, then composite of these two function GOF x is also a onto function. Clear students? So pause this video and note it down. Okay students, next result. So here we are given two function f and g such that composite of that function is g of f. GOF is defined and that composite function is 1 1. So here we have to check, it is necessary that both the given function f and g are 1 1. Done. So two functions f and g are given. Consider this is function f. Domain and codomain are 1 2 3 4. Here 1 2 3 4 and 5, and another function, suppose function g is there, whose domain is 1 2 3 4 and 5, and codomain is 1 2 3 4. Done. So two function f and g are defined. Their composite function is GOF is also defined. Now mapping is 1 with 1, 2 with 2, 3 is 3, and 4 is with 4. Here 1 is 1, 2 is with 2, 3 is with 3, 4 is with 4, and 5 is also with 4. So two functions f and g are given. These are the given functions. Done. So here we have to check if this composite function GOF is 1 1, so it is necessarily that both the function f and g are 1 1. So given function GOF is 1 1 function. So here for the GOF function, domain is 1. So GOF 1 is nothing but the g of f of 1, g of f of 1. For 1 we are getting 1, so f of 1 is 1, and g of 1 is 1. So here 1 whose image is 1, element 1 in the domain of this composite function having image is 1 in codomain. Let's try to check for the another element, which is 2, GOF 2. GOF 2 is nothing but the GOF of f of 2. f of 2 is 2, so it's a g of 2, and g of 2 is nothing but the 2. Now third element, GOF 3, g of f of 3. g of f of 3 is 3, so g of 3 is 3. Here fourth element, GOF 4, so it's a g of f of 4, g of f of 4, so f of 4 is 4, and g of 4 is also 4. Here function g is defined such a way g of 4 is 4 and g of 5 is 4. So here g of 4 equal to g of 5, that is equal to 4. So function f is 1 1 function. That means all the elements in a domain has unique and distinct image, while for this function g, each and every element has a unique image but not distinct, because these two elements has same image. So this is not 1 1. This is not a 1 1 function. This is 1 1 function. This is 1 1 function. And what about this composite function GOF? So here for GOF we can say it's a 1 1 order pair, 1 1, it's a 2 2, 3 3, and 4 4. So for this composite function, each element in this domain has a unique image in its codomain. Each and every element in domain has unique and distinct images in its codomain, and hence we can say composite function is 1 1. Composite function is 1 1. Done. So what is our conclusion? If composite function is 1 1, then it is not necessarily required that the given two functions are to be a 1 1, because here f is 1 1 function but g is not 1 1 function. In spite of that, their composite function is 1 1. Clear? So pause this video and note it down. Okay students, now fourth result. Now if f and g both necessarily onto, if their composite is onto, two functions f and g are given. If their composite function is onto, it is necessarily required both the function f and g to be onto, है ना. दो फंक्शन f and g है, अगर उनका composite फंक्शन onto है तो ये दोनों को onto रहना पड़ेगा, वो necessary condition है. So let's try to understand by one example. So 1 2 3 and 4, function f is there whose domain is 1 2 3 4. and codomain is 1, 2, 3, 4 and 5. Another function G is there whose domain is 1, 2, 3, 4 and 5 and codomain is 1, 2, 3. Mapping is f is 1, 1 function and this G is suppose many to one function. Done. So here G is defined as G of 1 is 1, G of 2 is 2 and G of 3 equal to G of 4 equal to G of 5 is equal to 3. So it's a many to one function. Now function f is 1, 1 function. So here f of 1 is 1, f of 2 is 2, f of 3 is 3, f of 4 is 4. Done. We have to check for the composite function GOF. So GOF is from A to C. Done. We have to check if GOF is onto function, then it is necessarily required that both the function f and g to be onto. So here GOF whose domain is A, so GOF 1 is there. So GOF 1 equal to G of f of 1. F of 1 is 1, so it's a G of 1 and G of 1 is 1. For the 1 in domain, we are getting 1 as a image in codomain. Now GOF 2 equal to G of f of 2. G of f of 2, G of f of 2 is G of 2 and G of 2 is 2. Third element GOF 3, that is G of f of 3, G of f of 3 is 3 and G of 3 is 3. Now fourth element GOF 4, that is equal to G of f of 4. F of 4 is 4, so it's a G of 4 and G of 4 is 3. Done. So that is our composite function GOF x. So here for each and every element in domain we are getting some image in codomain. Hence we can say for all the elements in codomain 1, 2, 3 having pre-image in this domain, and therefore we can say GOF is onto function. Done. Here given function composite function GOF is onto function. So whether it is necessary that both the function G and F both are onto. So let's check it. Now for this G function, all three elements in codomain has pre-image in its domain. So here G function is onto. Here function G is onto, but for this function F, all the elements in this codomain 1, 2, 3, 4 and 5. So out of that 5 element, this element 5 don't have any pre-image in this domain. So this function F is not onto function. Function F is not onto function. So function F is not onto function, function G is onto function, and that composite function GOF x is also onto function, and hence we can say this F and G both necessarily not required to be onto for the composition of that function to be a onto function. Clear students? Suppose this video